in our lab on semiconductor nanostructures, and these are primarily targeted towards optoelectronics and energy application. As you know, these days, clean energy is very important because of climate change and global warming. So we are also gearing our research targeting that area as well. Okay, so this will be the outline of my talk. So first of all, I will explain why we are interested in nanowires and how we produce nanowires. Basically, there are three approaches that we use in the lab. So two of them are the bottom-up approach, and one is the top-down approach. Okay, and after that, I will show you some examples of the devices that we make, in particular lasers, solar cells, and some photoelectrodes that we use for solar water splitting application. So after the nanowire presentation, then I will move to something called shape engineering. Instead of growing nanowire, I'll show you how we can grow other geometrical unique structure. Okay, this unique structure will give us the opportunity for new device architecture. And then finally, my talk, and I will show you some of the newer work that we've been doing the last 3 or 4 years on hexagonal boron nitride. So this is a 2D material, and we synthesize this boron nitride in my lab where we can grow wafer scale, okay, large scale. And I'll show you a few applications such as surface enhanced Raman scattering using the HBN as a passivation layer. Also single photon sources coming up from the HBN, and also using HBN as a template for growth for flexible devices. So why are we interested in nanowires? Okay, so first of all, nanowires have a very large surface area to volume ratio. So you can see here, this is an optical electron micrograph image of the nanowire. So you can see they are very small in diameter, and we can grow them very long. So in that process, they have very large surface area to volume ratio. So you can think about what application that's possible. For example, if you want to absorb more sunlight, okay, so large surface area is good. So think about solar cell. Or you want to make very sensitive sensors, biosensors, chemical sensors, whatever. Large surface area to volume ratio is good. Okay, so that's why we are interested in nanowire. And the other thing, as you can see here, this is a nanowire wafer.
Sorry to interrupt. You are moving the slides. We are still seeing the first slide only, I think.
Oh, okay. Only first slide.
Okay, fine. Please.
Yes.
Okay, so I can't put it in presentation mode, unfortunately.
Okay. It is coming slide by slide, no?
Do you see an overall, or it's just
Sir, we are seeing nanowires.
Yes, I know, but I will try to put in presentation mode. How about that?
Now it has become very small. Now it's fine.
Now it's
fine?
Now it's fine.
Okay, good. Okay, good. As I mentioned before, here, this is the nanowire wafer. You can see it's dark in color, and this is a planar semiconductor wafer. As you can see, because of the dark color nature of this nanowire, they can absorb more light. That's what it means. So again, if you think about applications such as solar cells or photodetectors, then this nanowire wafer